We have started the first day introduction part, network fundamentals. So I hope we have discussed very strong network fundamentals. The detailed day we discussed. So I hope everyone the strong fundamental you have in the networking, like IPv4 logics and IPv6 logics, the OSI, the layers functioning each and layer. So where segment will generate and what is segment and what is packet, no frame and bits conversions, the process encapsulation and decapsulation process. Okay, and like introduction to routers, we have seen router types and router functions, all about routers, internal external components and WAN technologies. So most network fundamentals we have seen. Later on, network routing protocols, IP routing, types of routing, conditions, static, dynamic types. The three routing protocols we have compared. Yeah, the next have seen LAN technologies. So the LAN technologies mostly almost all things we have seen, like a switch and switch functions and single broadcast domain and switch types, manageable and manageable switch, and switch categories. Like the Cisco uses three terms to define the switch role, like access layer, distribution layer, and core layer. So access layer is a layer 2 switch, and core distribution and core is a layer 3 switches. And the switch configuration we have seen. The switch behavior is a single broadcast domain. If increase your LAN size, it increase the broadcast domain size. To minimize the broadcast and to provide layer 2 security, VLANs is created. We have segregated our network. Have divided a single broadcast domain into multiple broadcast domains by creating a VLANs and implementing a VLANs. So VLANs will allow to the second switch, like multiple VLANs to communicate. We need to configure trunk encapsulation method. Trunk, that is .1 queue method. It's adding a headers to Ethernet frame, right? The next point is dynamic trunking, automatic trunking. One side if you configure, the other side will form automatically. And VLAN trunking, like VTP, is to maintain the VLAN configuration consistency throughout the network. Like if you create the VLANs in server mode, VTP server mode, it's going to replicate into all client mode switches. So we can create, we can delete, we can modify VLANs in only VTP server and transparent, but in transparent is local only. And we have seen inter-VLAN routing, how to allow different VLAN communication, routing between the VLANs in the different ways. And CDP, LLDP, and the loop avoidance protocol, which is STP and STP election process and STP drawback port fast. And these are channels like switch level load balancing protocol, PAGP, LACP. These things we have done in the LAN technologies. Later on, Cisco Security has been started. In that we have seen ACL, NATing, default routing, and some network services, IP services like a syslog service, NTP service, DHCP services, and AAA authentication. Yesterday we have seen about all switch level router security, password recovery. No, just a minute. Yeah. So like this, we have network securities and IP services. So almost we have done. Just some wireless network. Before that, the previous classes, all classes, if you have any doubts, anyone, you can ask me now. I'll give that 2 minutes. If you have any questions, and you can ask. The entire from day one to till today, if you have any doubts, any doubts, you can ask.
Sir, hello, hello.
Right, Prashant.
Sir, we are discuss as you say, we are discuss about the switches in switches, manageable switches, but I forgot it, sir.
The name itself is telling manageable. Means we can manage the traffic, users traffic. We can control the users traffic and can minimize the broadcast domain, and we can assign the IP address. We can set the passwords. We can segregate the network. So simple terminology is in manageable switch. We can manage users traffic based upon your office environment. We can control the users traffic also. Means manageable switch has a console port. We can configure it. We can enable telnet functionality also.
Okay,
Unmanageable, not manageable. We cannot manage anything actually. No console port.
okay. And sir, in Cisco switches, what is that 2960, 3950, switch 4510, 4010, switch 6506 and 6509? Means like we are seeing in routing some routing numbers like that the in switches, which one we are using small area network, then middle area network and large area network.
It's not like that. Actually, just before I explained in switches, there are three terms Cisco uses to roll off the switch, which is access layer switch is 2960. It's a layer 2 functioning. Means it can forward the frames based upon the MAC address information. It can understand the MAC only. Layer 2 protocols only can be work in access layer, which is 2960 switches. Is
Okay,
3580, like 3550. These switches are distribution layer switches, which comes under layer 2 and layer 3. These switches will be understand IP and MAC both. It maintains the MAC table and routing table both.
okay.
Layer also same. Yeah.
And
Any
sir,
more doubts?
66506 means.
This core layer switch.
Okay,
Yeah.
okay, thank you, sir.
Yeah. Anyone, please? Any more doubts? Okay. We'll continue with wireless, understanding wireless network. So the first day, do you remember we have started network fundamentals? The day one itself, I have given a few points, which is network, networking, internetworking, and again types of networks like local area network, wide area network. Same like in wireless network, we'll say types of networks. The first type of network we call the PAN, personal area network. The next is LAN, local area network. Metropolitan area network, MAN. Wide area network, WAN. Is all the networks in wireless? Wireless network types. Wireless personal area network, wireless LAN, wireless MAN, wireless WAN. Think everyone knows about personal area network. Wireless PAN, which is the best example is Bluetooth, which is a very short range. We can share your data. So to the Bluetooth, if you want to share the data, we don't require any authorized, we don't require any licensed signals because device to device there is to pair signals will be generated. So there we don't require any license. Do you remember? Like nearby you, any Bluetooth is on. If you switch it on, you can pair by accepting that message, and you can share the data also, right? In early days, without any authentication, without any permissions, also we used to take the file and we used to share the file also. Now the Bluetooth some developed and we have to accept that actually, request. So when initially when smartphones is developed, do you remember anyone? Like if you switch on Bluetooth, if I switch on the Bluetooth, when the device will near come by, then we can share without any permissions, like that other permission, we can send the data, right? So means we don't require any licensed signals in Bluetooth, but very short range. In all type of wireless networks, which is the most popular type of network is LAN, wireless LAN, because of where we use this wireless LAN. So in wireless network, completely in wireless network, which is the most commonly used network is wireless local area network is type of wireless network that is commonly used in the homes, offices, campus environments. So wireless make mobility possible with the home and business environments. The major advantage of wireless network is better mobility, right? Yeah, because of we can easily move from anywhere, flexibility is more, so more mobility is there. Wireless network used radio waves to connect the technological devices. So your device and another device is there, two devices to connect. Wireless network use what? Radio waves, the internet as well as your business network. These are the types of wireless networks, which is wireless PAN, which is supporting for 20 to 30 feet, 6 to 9 meters, and wireless LAN, medium-sized networks up to about 300 feet, 8.11, and MAN, wireless MAN, such as a city and district. So from here, we require specific licensed frequencies. So when the ISP service providers are exchange the signals from city-wise, district-wise, and use one licensed signals. So it is global communication, national communication. We used wireless WAN. Also required a specific licensed frequencies. Okay. And what are the advantages and disadvantages? Advantages: better mobility, easily move away from anywhere to anywhere. Like in real time, this is your business area. Like in office, in first floor, second floor, third floor, and fourth floor. And there is one. They'll keep one WLC, and here they used to kept one, two for each floor. Well is access point. And they are connected to access points. All access points are connected to controller. Now what you need to understand here it is the same like your physical network. This is your switch and your end user device are connected. Right? Now what end user's device will do if any one PC will generate the broadcast, it's going to impact in all device, right? And what we will do, we will divide into segregate the network based upon project wise, department wise into VLANs. So inside the switch, we are creating VLAN and managing, controlling. So inside the switch, we used to configure everything. Then device will be function. Loop avoidance, STP, these things is a physical network. What about your wireless network? So same like in the wireless WLs, like wireless LAN controller. So we used to configure, segregate the network, wireless device also. Even if a device is wireless, is a part of some other VLAN, VLAN 10, VLAN 20, VLAN 30. Okay, like complete all access points is being controlled by this device, which we call wireless LAN controller, which is more similar to like a switches. Now, one of the employees in ground floor. This is your device, and you connect it to these access point: access point 1, access point 2, access point 3, access point 4. Now you have connected to access point 1 and you got network access, everything is going. If you move to first floor to second floor, yes, automatically you will connect it to access point 2. Still you're the part of a network. Like if you move to third floor, then automatically your so access point will be connected. Still you're the part of a network. Still you're, so means mobility, more mobility. If you move from like enter your business, complete your business area, if you're roaming here, you're the part of a network only. You can access the resources, whatever availability. Your office servers, your printers, everything will be accessible actually. So there is a major advantage is better mobility and cost effective and scalability. What is the drawbacks? Reason for any security issues. Security issues is it? Means when wireless is being developed, they will just focus on the wireless technologies only. Nowadays we have the secure wireless also, but compared to wired, security issues in the wireless, less speed. Compared to wired, wireless is less speed and less control of your data. So why less control of data? Because of wireless signals travel as electromagnetic waves through the air from sender to receiver. The wire network, the medium is copper wire, any optical fiber. So the proper guidance is there. So through that, data will be passed. Here is what the medium is air. Through air, some electromagnetic waves has been traveling. So someone can destroy the signals because of when the data is going to the air is the medium, destroy the signals. So we don't have a much control on wireless technology, wireless data actually. Control is less. Control is okay, but compared to, I'm telling is compared to wired. So that is why in the real time your servers are connected to wired only. You know, in IT companies will be majorly preferred wire network. You know, some business area they used to wireless, okay, but end of the hitting the servers, your servers and the machines and your VMs, now everything is been connected to your wired network. Have you seen the data centers like all are connected to the wired devices? So what type of technologies we have in wireless? Bluetooth is one of the type of technology. Wi-Fi is which is very most popular technology in the wireless is Wi-Fi. Like WiMAX is also cellular broadband, we know that, and satellite broadband. So mobile data using with cellular broadband, GSM, CDMA, these things comes under cellular broadband actually. A satellite broadband, satellite signals. Yeah. But how exactly these wireless signals will be travel from sender to receiver? And what is the fundamental property of the wireless link which is involved? So these things we'll try to discuss clearly. So we know that wireless signals travel as electromagnetic waves through the air from sender, means source, to destination. If it is a access point, wireless access point, devices are connected. Now he is a sender, receiver. So wireless signals travels electromagnetic waves through the air. Through air, electromagnetic waves will be traveled. So for this, what is the fundamental property of these waves involved? Means here, when electromagnetic waves is been traveling, to define these magnetic fields, electromagnetic fields, fundamental property of waves involved in the wireless link is called it is a frequency. Okay. Yeah. So how this sender sends magnetic fields and these things, will see that magnetic field, how it looks. Yes. So this is a traveling electric and magnetic waves in a straight line. Main point is the signals must keep changing. So these electric and magnetic fields travel along together are always right angles to each other. When electric field is raising up, the right angle opposite, magnetic field will be traveled. When magnetic field is in raise up, electric field will raise down. So the signals is up and down. So they don't travel the straight line. They don't strictly travel the straight line in both. Okay. So in radio frequency, wireless communications, a sender we call transmitter. And this transmitter sends alternating current into a section of wire called antenna. It's sending a section of like alternating current into the section of wire called antenna. We set up moving electric magnetic fields. So when he's sending the magnetic fields like this, from this access point, it will be generated in all directions. The electromagnetic fields will go in this direction, in another direction, another direction. Like your access point will be send this fields in all direction, and your receiver is also here, is there, right? And he will receive it. So don't think like here is this receiver, so we need to send in direction only. Access point, whenever a sender, I mean transmitter will send alternating current in section of wire to antenna, then antenna will send in all dimensions, all directions. In one dimension, receiver is there, he will receive it. So electric and magnetic fields travel along together and always right angles to each other. Signals must keep changing, I mean alternating by cycling up and down. So to keep the electric magnetic field cycling, pushing pushing up and down, Then what happened? So these fields, the waves do not travel strictly in a straight line, always alternating actually. By expanding in all dimensions, all directions away from the antenna, in the air, in the free space, is all the free space in all directions they are sending actually. Okay. Now I'll see this, how to measure these frequencies. Yeah, in all dimensions like this. The sender sends alternate current in the section of wire called antenna. It is going to sending in all directions. What happens in sending alternating the signals, electric signals, magnetic signals, electrical signals, magnetic signals. In all directions, in all directions. So here receiver is there, he will respond if everything is good. Okay. Now let's see how to measure the frequency. The waves involved in a wireless link. The waves, what are the waves is involved? Is all the waves. What are the waves involved in the wireless link? Can be measured and described in several ways. One fundamental property is the frequency. Frequency of the wave. What is the frequency of the wave? The number of time signals makes a complete up and down cycle in 1 second. It's a frequency. I repeat, what is the frequency means? The number of times. If you take in straight line, number of times the signal makes one complete up and down cycle, up and down cycle in 1 second. In 1 second, how many times is going like up and downs? So how many cycles is happen now? Like up, down, up, down, up, down, up, down, up, down, up, down in 1 second. So how many times it's been happen? That is a frequency actually. So clear example, if you take one straight line, now one complete cycle begins, can begin at a signal rises from the center line. From center line, signal raised, rising now signal, falls through the center line, falling down, and raise again to meet the center line. To meet the center line, I can raise it. These we call one cycle. Complete up and complete down to meet the center line. So this is one cycle. Most commonly used frequency unities, hertz. So number of cycles per second is number of hertz. Okay. Now again from straight line, signals is raise up, fall down, again to meet the center line. Example, again the signals is raise up, down, again center line. Again the signal is raise up, fall down, meet the center line. So this is a happening in let's example this happening in 1 second. From here it started. It isn't it? This is we call the cycle.
Madam.
Yeah,
So gigahertz means 1000. Giga means 1000 only.
I'll tell you that.
Okay.
So is one cycle. Now if it is from here to here, how many cycles is done? In 1 second, this has happened. So how many cycles?
4.
Yes. So now here frequency is 4 cycles per second. Means 4 hertz. So 4 hertz here. Means number of cycles is number of hertz per second. Okay. Now I'll see this frequency table. The units we called abbreviation, a meaning, hertz indicates like hertz. What do you mean by hertz? Meaning is what? Hertz meaning is what? Means by mean what?
1 cycle per second.
Not only one cycle, number of cycles per second. Number of cycles per second is hertz. Yeah, exactly. Okay. If it is kilohertz, kilohertz.
1000 cycles per second.
Yeah, 1000 hertz means 1000 cycles per second. For 1 second, the complete up and down happens 1000 times for 1 second. If it is a megahertz, mHz, million cycles per second. 1 million hertz means per 1 second, yeah, up and down cycles. Like the cycle happens in 1 million times for 1 second, like gigahertz, GHz, 1000 millions, 1 billion times you can say. One million, 1 billion. So now whatever the equipments we have, what are the devices we have, the devices can support megahertz and gigahertz, like 2.4 gigahertz, 5 gigahertz. So per 1 second, the cycles happen in up and down cycles happen in 1,000 million times. Okay. So say this example here, how many cycles is done for 1 second? 1, 2, here to here 1, again here to here 2, 3, 4. So 4 hedges. Like for 1 second, if it is 2.4 gigahertz, means what? For 1 second, 2.4 billion times is cycles is done. Okay. So like this, we can understand frequency unit names and understanding of frequency. So what is frequency and frequency units, abbreviations, meaning like this. So let's see now frequency standards, IEEE standards of wireless technologies. 802.11 is the wireless. So first initially we have 802.11, 2.4 gigahertz is radio frequencies RF, and data rate is up to 2 Mbps only. Eight not dot 11 A, 11A, 11B, 11G. These amendments are initially is being developed. I mean, maintaining of access point client capability up to 11G. Can see data rate up to 54 Mbps only. 54 Mbps, 11 Mbps, like this. Yeah. This 11N amendment, 11N, 11AC, no, 11AX. So when it happens, let me see that points. 802.11, it's 2.4 gigahertz, and it is 2 Mbps. It's also 54 Mbps. It's 11 Mbps only. 54, but these all are 2.4 gigahertz only. Sub A. But we have some advanced technologies being developed. In 2009, 11N amendment was published. So effort to scale wireless LAN performance, the maximum of 600 Mbps. 150 to 600 Mbps can develop, support it. So that is why we call it as a HT technology. Means high throughput. And the frequency range is what 2.4 and 5 gigahertz can support. Then later on, in 2013, 8.11 AC amendment was introduced. This brought even higher data rates to more advanced modulation. It's very more advanced modulation. So greater data aggregation during the transmission is available. So this AC is known as VHT. It's a HT, high throughput. This is very high throughput. And later on, 802.11 AX amendment, which we call Wi-Fi 6. It's a high efficiency wireless. High efficiency wireless, HW, HEW call it is. No, 1 gigahertz to 7 gigahertz frequency can support it actually. So why it is supporting very high before 802.11n? Before N, what are the technologies we have? These are the technologies wireless devices used a single transmitter and a single receiver. If we use a single transmitter, single receiver, resulting in a single radio chain. So this type of technology we called single in, single out, CISO. Single input, single output. So one of the secret to better performance of 11N, 11AC, 11AX is these technologies comes under use. Okay, what is the secret of better performance of N and AC and AX is uses multiple radio components forming, resulting is what multiple radio chains will be developed. This is known as MIMO technology. Required multiple antennas with the MIMO technology. Means multiple input, multiple output. You can see this diagram. TX transmission, transmitter and receiver. Single transmitter, single receiver. This is normal traditional wireless technology, 802.11. So single in, single out. Here, multiple like 2 by 3 transmissions to receivers, say, like transmission 1, transmission 2, receiver 1, receiver 2, multiple in, multiple out. These are examples of CISO1 remote devices. Now, wireless topologies. In WAN topologies, we have seen hub and spoke topology, full mesh topology, partial mesh topology. So here in wireless, like one device to another device, directly on your laptop and your friend's laptop is connected. Like in the first figure, two devices are directly connected without any device. So this is attack mode. Used to connect client in peer-to-peer manner without access point. Without any access point, they are connected. Infrastructure mode we have used to connect clients to network using access point. The tethering, variation of attack topology in when a smartphone or tablet used to seller simply in creating hotspot, laptop to mobile phone and mobile phone to laptop, like internet hotspot, wireless technologies. What are the wireless components we have? Wireless NICs, wireless antennas, wireless router, access point, controller. These are the wireless network components. Wireless network card to communicate wirelessly. Laptops use laptops, tablets, smartphones. All devices we use NIC cards. When external NIC also we can use. If a device does not have integrated wireless NIC or if it is failed, then you can use USB wireless adapter can be used. Wireless antennas, as we discussed, like single receiver, single transmitter, or multiple receiver, multiple transmitters. This type of antennas, like omnidirection, 360 degrees coverage. No, ideal for houses and offices area. This is antennas. And directional, which is your traditional antenna, the olden days TVs. So if you move this direction, then picture will come. Again you are moving on, and we'll fix on one direction. That is directional. Focus on the radio signals in a specific direction only, like a dish. So multiple input, multiple output, MIMO technology. Up to 8 increase the bandwidth. This is multiple in, multiple out. Okay. Nowadays we are using for dish, for the TVs and homes we are using for this now, omnidirectional. Home user typically connects wireless devices using a small wireless router and access points and switches routers. We know this. This is a wireless router. How to connect it? Yeah. Generally we use at homes, office premises to connect wireless devices. Same like every router must should have three type of ports: LAN, WAN, admin. Router LAN port is fast Ethernet port. WAN ports are serial port. Admin port is console port. That we know. What about for wireless devices? Even wireless device also there is WAN port is a LAN ports are say admin. So there is no special admin port and connect a device to the LAN port. You can open the web browser. There you can give your IP of this router IP. Then you can get access of router. Graphical only can support it. We don't have any specific admin ports in this type of devices actually. This is some pre-configured. Means DHCP is already configured. Just to connect your device and request to DHCP IP, and DHCP provide IP address and check your IP address. How to configure wireless, how to connect and how to configure is IP config. So here you have IP address, the gateway of, you can open the web browser. One 192.168.0.1. Your password. Yes. Do you know what is the use of this command? Normally in the Cisco routers, we use this command, right? What is the purpose? We can get off LAN interface information, WAN interface, or interfaces status information, right? The same thing here. The status, here we can have LAN configuration, wireless LAN configuration, WAN interface configuration, all interfaces information here you can get. First, your local area information is IP address in so and so network and so and so subnet, and DHCP server is enabled. MAC address of the device. Wireless LAN, wireless configuration. Wireless is enabled and mode is access point. So and so SSID. And the encryption, channels, broadcast, APS. Yeah. And wireless WAN configuration. So this is WAN interface. Protocol is DHCP. We are getting automatic IP, MAC address, and status. What is status? Status is link up. DHCP client. Remember in DHCP we discussed router can be configured both as server and DHCP client, right? Yeah. If you go for setup, you want to configure anything. Setup, local network setup. Like LAN interface. Generally, you want to change IP address. What we'll do? Interface fast Ethernet 0/0 IP address Already 10 dot is there. So we want to make it into some class C network. Then you can do, want to make it is a in subnet. You can do like this. So in wireless router, you can do like here actually as an IP address and subnet mask changes. DHCP. Generally, how is to configure DHCP in router? IP DHCP pool name, some name, and network, so and so network, so and so subnet mask, default router. When your router IP, the first two, what do you have assigned? These things, right? Similarly here, IP DHCP mode, IP pool range, so and so range, 0 to 255. Means I am in 0 network. You want to change? You can change here, 2 dot network. Here, change here, 2 dot. Maximum lease time is 120 minutes. Have a DNS server, optional too. Like we can get it actually. Internet WAN interface configuration. We want to assign the static manually, you can go for DHCP and static IP or triple PoE. Like you can use this actually, static IP. But as per dynamic client is there. Okay. So like this, we can configure wireless and password changing here, Wi-Fi password. Almost all options is there. If you just go through these options, you can get it. Okay. So this is a basic understanding of wireless only, and if you have a separate course for complete wireless technologies, so just only basic understanding. This is all about wireless. If you have any doubts, you can ask me now. Yeah, I'll see now next port security. How to provide our port security, switch port security. The example of switch port number 1, port number 2. For device 1, port number 1 have connected a device. Port number 2. To minimize the broadcast and to provide security department wise, first 3 pieces consider there are junior engineers. Here we are 5, 6 on these are senior admin. By default, all ports in the part of what? VLAN 1. If all are VLAN 1, then all users can communicate now. There is a server in port number 8. So now all 1 to 8 ports in the part of VLAN 1, then senior engineers can access, junior engineers can access server. But I want to allow only for senior engineers to access the server, then what we need to do? Segregate the network into VLANs. So create VLAN something VLAN 20 5 6 7 8 means port number 8 also have moved. I have implemented VLAN 20. So 5 6 7 8 is a part of what now in VLAN 20, right? For 1 2 3 ports, junior administrators are create one VLAN. Port number 1, port number 2, port number 3 is VLAN 10. Now VLAN 10 users, is there any chance to access the server? What are the possibilities? Any possibilities is there? Think about it and tell me.
Yeah, through routing switching.
Yeah, inter VLAN routing, right? Yes, if you do inter VLAN routing, then they can communicate. VLAN 10, VLAN 20 users. Okay. The first possibility is inter VLAN routing. Any other possibilities? Junior engineers can access server. Yes, please. Okay. So now if I change, it is a VLAN 20. Made it is a VLAN 20. Will they communicate? Yes, this is VLAN 20, this is also VLAN 20. Or if I change the VLAN 10, yes. Or no VLAN 10, no VLAN 20. All become in the default VLAN 1. They can. So what are the possibilities is changing or removing VLANs. Our main point is what here, junior engineers, how we can access a server. So junior engineers has only a switch user level only. In the switch user level, if the junior engineers can do inter-VLAN routing concept, not possible. Being in the user mode, can they change the VLANs? Not possible. Can they remove the VLANs? Not possible. Then how? What is the possibility for junior engineers to get server access? No, there is no chance without permission from the seniors. No? But what these junior engineers is doing is very talented engineers. They removed the cable in PC5. They have device remote. The junior engineers is connected to port number 5. Whenever he is not available and he is connected actually. But port number 5 is connected. Now junior engineer is a part of which VLAN?
VLAN 20.
VLAN
20.
20. In VLAN 20 we have server is there. Now we don't require any permission from senior administrators. Now we don't require any configurations. No inter-VLAN routing, no removing of VLANs, no changing of VLANs, nothing. Just connect a cable to the port number 5 or 6 or 7. You can have access of all the resources in VLAN 20. You're the part of VLAN 20. So PC port number 5 don't know this user is a junior engineer, this user is a senior engineer. So port does not understand that. Port number 5 understand what? I'm a part of VLAN 20. In VLAN 20, what are the resources available? I'll forward to that resource. But port number 5 don't know this user is an unknown user. Problem. What we going to do? We want to secure our ports. Like this type of we call MAC flooding, MAC flooding attacks. So how to prevention this is port security. Every devices have unique MAC address. Example, first device MAC address is A1, B1, C1. So here C2, A2, B2, C2 MAC addresses. So what is the port number 5 PC MAC address? A2. Interface fast Ethernet 0/2. Sorry, port number 5. Port number 5. MAC address is A2. You are binded. So now MAC address A2 is being binded to port number 5. Right? Yeah, now port number 5 knows only A2 MAC address. A2. Now this A2 user is trying to access server, which is senior administrator using server access. Now what is the source MAC address? A2. Destination MAC address is ARP. Packet is generated. We'll come to port number 5. What port number 5 will do? We'll check. Are you coming from which MAC address? I'm coming from A2. Yes, I know A2. You are my authorized. You are authorized user. Because of port number 5, A2 is been binded. Yes, you are authorized users. Now 5 will forward the traffic to respected destination. But what if this hacker is doing now? C1 removed and he got connected here. After connected, now he is trying to access server. Now what is source MAC address? C1. What is destination MAC address? ARP. Packet is generated. Come to port number 5. What port number 5 will check? Are you coming from where? I'm coming from C1. Who you C1? Who are you C1? I don't know C1. I know only A2. You are my unknown. You are unauthorized. So whenever unknown source MAC address is coming to the port, it just will drop the traffic. It cannot be forwarded. So now your port number 5 is secured. So port security based upon the MAC address, MAC binding. But my requirement is, see, I'm not using this PC. I want to use my colleague. He's also senior administrator. This PC I want to use. If we connect to port number 5, from this PC can access to server from B2? It's a senior administrator PC. But if you connect to port number 5, can I access the server? No. Because of port number 5, don't know you are the senior, you are the junior. Na? What 5 knows? Only A2. But traffic is coming from B2. Drop it. But we can bind B2 also here. We can bind C2 also here like this. If you're binding the multiple MAC addresses, then it's most similarly like here fingerprint access to your mobile phones. Like multiple fingerprints we can add, right? Like this. So port security is used to control network access based upon number of MAC address, based upon number of MAC address per port. Okay. But security actions can done in 3 ways: shut down, restrict, protect. 3 possible devices there. I'll tell you how it works. Let's consider port number 5 is under protect. Now how protect works? Now port number 5 is under protect action whenever unknown MAC address. Okay, C3. Unknown MAC address is connected. Oh, you're coming from C3. You're my unknown MAC address. And yeah, port number 5 LED will not change anything actually, no? It's just blinking only. There is no changes for unknown devices connected, then continuously blinking. There is no change like this, no indications like this. If it's known devices connected or unknown device connected, same state of the LED. But simply dropping the traffic for unknown source MAC address. That's how protect works. Protect unknown source MAC address frames is dropped, no changes in LED. What if you configured with restrict? Now we are in restrict mode. Restrict also similar to protect. How protect works? When unknown MAC address is connected, there is no changes in LED, simply dropping the traffic. Same thing, restrict also will do. The difference between protect and restrict is, in restrict, which user is which user is trying to accessing your port, that log information will get. Okay, just a minute. So here C3 is trying to connect here to port number 5. Now restrict will generate the log message. So and so on C3 MAC address, so and so on date and so and so on time. 5 times is trying to access, 6 times or 10 times violation happens. Like, or C1 is trying to access, or B1 or A1. Like which MAC address is connected to your device, that information we can get log messages. Remember failure logs. Like similarly, when unknown MAC address is connected, we'll get the notification messages. In restrict, in protect, no logs, just simply dropping that frames, that's it. Or one more violation is we can make the port is shut down. When unknown device is being connected, then your LED will be turned off, completely off. So 3 actions we have. Shut down, the port becomes error disabled state and LED and port LED turns off. Protect. Frames with unknown source MAC address are dropped, it does not notify. Restrict also same, unknown MAC address is dropped, but it gives a notification log message that security violation has occurred. You can see this configuration. Like interface FE0/5, switch port mode access means your port should be access port only. Then we can provide the port security. If it's a trunk mode, no, we can't do that actually. It should be mode access. Switch port security maximum. So one port can support maximum is 132 MAC addresses. 1 to 132 MAC address can support. Okay. But how many MAC address you're binding? We can do that. If you're binding 10, maximum value is 10. If you're binding 2, if you're binding 1 and only is the 1 MAC address. And your MAC address are equivalent for protect or restrict and shut down. Finally, to enable switch port security. Okay. I'll show you one small practical on this port security. Three computers. One dot 10 first computer IP, second computer IP, 1.20, port number 3, 1.30. Now all device can communicate, device 1 to device 2, device 1 to device 3, device 2 to device 3. Successful. The point is now I want to make my port number 2 secure. So no one should not communicate. My PC MAC address will get here, show MAC table. So port number 2 MAC address are copied. Switch port mode access, switch port security, maximum. I'm binding now 1 MAC address, and switch port security, MAC address, so and so MAC address, and switch port security violation. I'm going to make a shutdown switch port security. That's it. Mode access, maximum is 1 and MAC address, and violation is shutdown. And the enable port security. Now port number 2 is secured. What someone is doing is he removed the cable and this user is connecting to my device to port number 2. Connected, okay. Why is connected? He's trying to use the server resource. Now, whenever he started sending some ping packets or any request has been started, then your traffic is been dropped and your LED will be turned off. So example 1.10. Enter. Now you can see the LED, consider an LED. See, once I enter ping, the port is blocked. Right? So like this, we can understand port security. Like in the switch, if we check show port security, port number 2, security action is shut down. Like we can check that action. Okay.